Another advantage of this nail is that not only those screws that thread in, but these wires here that you can see, those distal wires, those are outside the nail. So you can still almost help pin your fracture and see where the nail is going to end. And that's what that most distal wire, you can see where the tip of the nail is. So you're never proud. And I think it just provides you a little bit more flexibility, both with the screw orientation as well as hopefully gaining more length. Because, when you have a comminuted fibula that's harder to reduce, when you're putting the nail in, those fractures will tend to shorten. So I think there are some advantages there too. And, in terms of maintaining length, as you mentioned, even that more proximal transverse wire that's outside the nail. I think that gives you a lot, once again, more flexibility. And you can see that wire here. It's anterior to the nail, so it's out of your path of your screws, but it does hold your length. And I think that was a really nice feature, especially in this fracture, which, if we go back to the one of the original X-rays of the 3D recon, especially, you could see that this is a very comminuted fibular fracture. And I think, it was mentioned like, okay, not only how you reduce this, I think with clamps, as was done, but how it holds reduction is a lot of it's ligamentous textus. We've gotten the fracture out to length and then fixated with the nail. And so, since it can't really shorten, and I think the nail has proven that, right? It doesn't shorten, those fracture fragments have kind of been teased into place with those clamps. And then the nail is holding it out to length, and those fracture fragments have nowhere to go. And I think that's one of the, a very good, strong point of this nail, of holding the length that you've gotten, as well as the alignment